Welcome to CSE Guru. In this session, we will discuss traveling salesman problem using dynamic programming approach. Traveling salesman problem is nothing but the salesman has to start from one city that will be considered as the starting city. So here the starting city will be considered as vertex 1. So the salesman has to start from one city, that is starting city. So from that city, he has to visit all other cities in the given graph and come back to the starting city. And that path should be the shortest path, minimum cost path. That is nothing but traveling salesman problem. And this traveling salesman problem, we are going to implement using dynamic programming approach. So here, consider a graph G with vertices and edges, G of V, E. V is nothing but the vertices. Here vertices are 1, 2, 3 and 4. And the edges here they have given us 5 edges. 1 to 2, 2 to 3, 3 to 4. In both the directions the salesman can travel. Okay, 1 to 2, 2 to 1. Similarly 2 to 3, 3 to 2. Likewise, these are all the edges given in the graph. And assume that here the source vertex is nothing but 1. Always the source vertex or the starting vertex will be 1 we need to consider. And here tour is defined as a simple path that starts and ends at the source vertex 1. So tour, if you are considering in the sense, that is a simple path that will start at the starting vertex, visit all other vertices in the given graph in any order. But he has to visit all other vertices only once and come back to the starting city. That is nothing but a. And here we need to consider the key points. Tour start from any of the edge where k belongs to v minus 1. That is, if you are visiting the kth vertex in the sense, this vertex should belongs to the vertex set and it should be subtracted from this vertex set. For example, if you are considering tour starts from 1 and he has to visit the remaining cities 2, 3 and 4. Okay. Suppose if you have visited 3 in the sense, this should be subtracted from this vertex set because he has to visit each city only once. That is the concept. Okay. Next, he has to visit either 2 or 4. That's why we have placed here v minus 1. Next, there is a path from vertex k to 1. If you are visiting the kth vertex in the sense, from the kth vertex, he has to return back to the starting city. That should be a path. Okay. Through each vertex in v minus 1 comma k. And G of I comma S be the cost of a shortest path. So here this is the main aim here. Cost should be minimum. That is the shortest path. So G of I comma S be the cost of a shortest path starting at vertex I. So this I will be the current visiting vertex. Going through all other vertices in S. S if we are considering in this sense, that is nothing but the vertex set. And terminating at vertex 1. That is after visiting all other vertices, come back to the starting vertex. So tour has to end at the starting vertex. That is the meaning. So here minimum cost tour is nothing but the function g of 1 comma v minus 1. So v minus 1 in the sense, suppose if we are visiting the current vertex is 1 in the sense, that should be subtracted from the vertex set. That is the meaning. So v minus 1 if you are considering in the sense, 1 you are currently visiting. V minus 1 is nothing but 2, 3, 4. So g of 1 comma v minus 1 is equal to minimum of 2 less than or equal to, that is 1 you have visited, next you have to visit 2. So 2 less than or equal to k, less than or equal to n. And C1k, 1 you are visiting, next you have to visit the kth vertex. The kth vertex may be next vertex the salesman is going to visit maybe 2, 3 or 4. That is nothing but k. So C1k plus g of k comma v minus 1 comma k. So 1 currently you are visiting and next you are going to visit the kth vertex. So both the vertex you have to subtract from the vertex set. That is the meaning. So g of k comma v minus 1 comma k. And here this above relation can be generalized as g of I comma s. So I here if you are considering in the sense, so 1 will be considered as I. The currently visiting vertex will be considered as I. And s is nothing but v minus 1. That is, which is the current vertex you are visiting, that should be subtracted from the vertex set. So that is nothing but s. So g of I comma s is equal to minimum of c of ij. So I is the currently visiting vertex and j is nothing but the next vertex you are going to visit plus g of j comma the next vertex visiting vertex comma s minus j. from the vertex set, subtract S, because next you are going to visit J. So subtract J with the current vertex set. And this is the relation we are going to implement. Okay. So here J belongs to S here. And the best case if you are considering in the sense G of I comma phi. So I is nothing but the current vertex you are going to visit. Next, there is no vertex to be visited in the sense that is empty set. Suppose the tour starts from the starting vertex 1 and next you are visiting 2. After 2, there is no other vertex to be visited. In that case, you have to include phi. Okay, that is in the given graph. Apart from the starting city, there is only one more city. In that case, this is the case. This is the function we have to use. The salesman has to come back to the starting city. So in that case, this is the best case and this is the function. So now we will discuss an example to implement traveling salesman problem using dynamic programming approach using these functions. Solve the following traveling salesman problem which is represented as a direct graph and whose edge lengths are given by cost adjacency matrix. So here they have given 4 vertices and the tour cost, they have given it as a cost adjacency matrix. So here what we are going to do it in the sense, first we need to consider 1 as the starting city. Okay. So from that starting city, visit all other vertices. These 3 vertices in any order you can visit. Okay. All the combinations we have to check it out. Any order you can visit and come back to the starting city. So that we are going to implement with the dynamic programming approach. So step by step we will consider. First, we will start with the starting city. Next choice may be either you can visit the second vertex or you can visit the third vertex or you can visit the fourth vertex. After visiting the first city, next city may be 2, 3 or 4. After visiting the second city, what is the remaining cities? That is 3 or 4. Next, you can visit 3 or 4. Here, after visiting the third city, next choice is either you can visit 2 or 4. Similarly, here 2 you can visit or 3 you can visit after visiting fourth city. So, any order if you are considering in the sense, first will be the starting city and last will be the starting city. And here in between if you are considering in the sense, different combinations of the cities to be visited. But it has to be visited exactly only once. That is the meaning. So here, 1 you have visited, 2 you have visited, 3 you have visited. What is the remaining city to be visited? That is 4. Similarly, here if you are considering in the sense 1, 2, 4, 3 you have to visit. Remaining city. Here 1, 3, 2, 4 you have to visit. Here 1, 3, 4, 2 you have to visit. Here 1, 4, 2, 3 you have to visit. And here 1, 4, 3, 2 you have to visit. And after visiting all these cities exactly only once, you have to come back to the starting city. So this is the actual logic. And this state space tree, if you are considering in the sense, we are constructing in reverse. From the bottom level, we will start to construct. And in this level, if you are considering in the sense, this will be case 1. So case 1 is nothing but after visiting all other vertices, it may be a fourth vertex or it may be a third vertex or it may be a second vertex. After visiting that, you need to return back to the starting vertex. That is nothing but case 1. And in case 2, if you are considering in the sense, already we have visited 2 vertices and then you are visiting the third vertex. That is the last vertex in the given graph. Okay. That is the meaning. That is case 2. And in case 3, if you are considering in the sense, you have visited the first vertex and the second vertex. Now we are visiting the third vertex. After visiting this third vertex, one more vertex is there to visit. Okay. So that is nothing but case 3. This cost we will calculate in case 3. And case 4, if you are considering in the sense, after visiting the first vertex, what is the next vertex you are going to visit? That we will consider in case 4. That is 1 to 2, 1 to 3 and 1 to 4 we will calculate the cost. Okay. And case 3 if you are considering any of these vertices already we have visited. After visiting that particular vertex, what is the choice? If you are visiting 2, choice may be 3 or 4. If you are visiting 3, choice may be 2 or 4. If you are visiting 4, choice may be 2 or 3. And what is the cost we will calculate? This state space tree, the cost we are calculating in reverse. That is the meaning. So first we will consider case 1. Case 1 is nothing but from any of these vertex you have visited last, and then you need to return back to the starting vertex. That is the meaning. Okay. So we will construct it reverse. Keep in mind. So here, if you are considering in the sense, number of nodes here is 4. That is 1, 2, 3, 4. And the cost adjacency matrix is given. Consider case 1. So case 1, if you are considering in the sense, S is nothing but 5. That is, after visiting the current city, next there is no other city to be visited. Graph consists of only 2 cities. Likewise, you imagine G of current city is nothing but maybe 2. And after visiting 2, there is no other city. That's why empty set. And after visiting 2, you have to come back to the starting city. That's why we have included 1. So G of 2, 5, 1. What is the cost here? It is 5. So C21 is 5. Similarly, if you are considering the third city, G of 3, 5, 1, if you are considering this is C31. After visiting the third city, come back to the first city. Cost is 6. Similarly, G of 4, 5, 1. After visiting the fourth city, come back to the first city. So, cost here is 8. Next, consider case 2. Modulus S is equal to 1. That is, after visiting the current city, there is one more city to be visited. In that case, we need to consider. What is the function we have to implement? G of I, S is equal to minimum of J belongs to S. Cij plus G of I, S minus J. So this is the function we are going to implement here. Okay. So here our assumption is we have started with the starting city and the next city you are going to visit. After visiting the next city, next one more city is there to visit. So that S is equal to 1. The remaining city to be visited is nothing but 1 apart from the current visiting city. Okay. So when I is equal to 2. If you are visiting 2 in the sense, what is the remaining city to be visited? Either it is 3 or 4. Okay, here at the time we are considering only one city. Next remaining city is only one city. Likewise, we are considering it may be 3 or it may be 4. Okay, so G of 2, the remaining city to be visited is 3 in the sense. That is minimum of J belongs to 3. That is the current city we are going to visit is 3. You have visited 2. Next you need to visit 3. Okay. So in that case, C of 2, 3. So 2 is the current city we are visiting and next we are going to visit 3. C of 2, 3 plus G of 3, 5. Meaning is after visiting the third city, there is no other city. That is the meaning. Okay. So here if we are considering in this one, C of 2 to 3. Cost of 2 to 3, cost is 9 plus G of 3, 5. So here we have considered G of 3, 5 value is 6. So 9 plus 6 if we are considering that is 15. Next, I is equal to 2. Here we have considered third vertex. Suppose if the choice is fourth vertex in the sense, after visiting the second vertex, if the choice is fourth vertex in the sense, there is only one more vertex to be visited and the choice is fourth vertex in the sense, this is the case. That is minimum of J belongs to 4. 4 is the next city you need to visit. C to 4 plus G of 4, 5. Okay. So here C to 4. 2 to 4 cost is 10 plus G of 4, 5 cost is 8. So we will get 18. Next, ith vertex, if you are considering it as 3, it may be G of 2, 3. The current vertex is 3. 3, either you can visit 2 or otherwise after visiting 3, you can visit 4. Only 2 other choice. Okay. So both the choice we need to find the cost. So here minimum of J belongs to the next vertex to be visited is 2. Then C of 3, 2. After visiting 3, you have to visit 2. 3, 2 plus G of 2, 5. After visiting 3, you have to visit 2. After visiting 2, there is no other vertex to be visited. That's why we have included 5 here. So G of 3 to 2, cost is 13 plus G of 2, 5, the value is 5. So the cost we will get it as 18. Similarly, here if you are considering minimum of j belongs to 4, okay, and here c of 3, 4 plus g of 4, 5. That is, after visiting 3, you have to visit 4. After visiting 4, there is no other vertex to be visited. Okay. So, C of 3 to 4 is value is 12 plus G of 4, 5 is value is 8. So, the cost is 20. Similarly, here I will include. Similarly, when I is equal to 4, after visiting 2, you can visit 3 or 4. After visiting 3, you can visit 2 or 4. Fourth vertex to be visited in the sense. After visiting 4, you can consider G of 4, next vertex to be visited is 2. You can consider, or otherwise G of 4, next vertex to be visited is 3. You can consider. So here, minimum of J belongs to, what is the next vertex you are going to visit? After visiting 4, it is 2. C of 4, 2. 4 is currently you are visiting. 2 is next vertex to be visited. Plus G of 2, 5. After visiting 2, there is no more vertices. That is the meaning. So C of 4 to 2 cost is 8 plus G of 2, 5 cost is 5. So we will get it as 13. Similarly, here we will consider minimum of J belongs to 3. C of 4, 3 plus G of, currently you are visiting 4. After visiting 4, you have to visit 3. After visiting 3, there is no other vertex. That is 5. So if you are considering C of 4, 3. 4 to 3 cost is 9 plus G of 3, 5 cost is 6. So 9 plus 6, that is 15. So this is case 2. So case 1, if you are considering, you have started from the starting city. After visiting the starting city, it may be 2, it may be 3, or it may be 4. That is only one vertex you are going to consider, and the next is 5. That is the meaning. Case 2, if you are considering in the sense, you have visited the starting city. After visiting the starting city, next city you are going to visit is 2. After visiting the next city, there is one more city to be visited. It may be either 3 or 4 if you are considering 2 as the current city to be visited. Suppose if you are considering 3 as the current city to be visited, choice may be 2 or 4 next. In that case, this is the function and this is the cost. Similarly, if the current city, if you are choosing to be visited is 4 in the sense, next choice may be 2 or 3. In that case, this is the cost. Okay, this is case 2. And next we will move on to case 3. In case 3, we have to consider after visiting the current city, there is 2 more cities to be visited. Likewise, we need to consider. Next, case 3. And these are all the values we have found out in case 1 and case 2. So with this reference, we will find the case 3 values. And case 3, if you are considering in the sense, modulus S is equal to 2. And G of I, S, the function, what is the function we are going to use? That is minimum of J belongs to S and Cij plus G of J, S minus J. Okay, this is the function we are going to implement here. And case 3, if you are considering in the sense, when I equal to 2, that is, the next city you are going to visit is 2. After visiting the second city, there is 2 more city to be visited. In that case, we need to consider, that is, G of 2, the remaining city to be visited is 3 and 4. That is, minimum of J belongs to 3, 4. That is, the next remaining city is 3 and 4. Current city going to be visited is 2 and the next city is 3. After visiting 3, you have to visit 4. That is the meaning here. Okay. Plus G of, after visiting 2, you have to visit 3. And then after visiting 3, you have to visit 4. If you are considering the third city to be visited after visiting 2 in the sense, this is the function. Okay. Suppose, if you are considering after visiting 2, you are going to visit the fourth city. Okay. Plus G of 4. After visiting 4, what is the remaining city? That is 3. This is the case we need to consider. So here we will get minimum of C of 2, 3. 2 to 3 cost is 9 plus G of 3, 4. What is the value? 3, 4 value is 20, comma, C of 2 to 4. 2 to 4. What is the cost? It is 10. Okay. Plus G of 4, comma 3. 4, comma 3 cost is 15. Which one is minimum? We will take it. Okay. So here if you are considering minimum of 29, comma 25. Which one is minimum? 25 is minimum. So G of 2, comma 3, comma 4 value is 25. Next up, consider when you are going to visit the city, third city. If you are visiting the current city is 3 in the sense, the remaining city to be visited is 2 and 4. So, minimum of J belongs to 2, comma 4. See, after visiting the third city, you can visit either 2 or 4. So, C 3, 2 plus after visiting the second city, you can visit fourth city. G of 2, comma 4, comma C 3, 4. Here, after visiting the third city, you can visit 2. Here, after visiting the third city, you can visit 4. Plus, the remaining function, if you are considering in the sense, after visiting fourth, G of 4, comma 2. You need to visit 2. So, here we will get it as minimum of C of 3, 2. 3 to 2, cost is 13 plus G of 2, comma 4. Cost is 18. 3 to 4, cost is 12 plus G of 4, comma 2, cost is 13. So, minimum of 31, comma 25. Which one is minimum? 25 is minimum. Next, case you have consider I is equal to 2. Next, I is equal to 3. Consider I is equal to 4. That is G of 4, comma. After visiting 4, what is the remaining cities to be visited? 2 and 3. Minimum of J belongs to 2, comma 3. That is, after visiting 4, you need to visit the remaining city 2, comma 4. C of 4, 2 and 4, 3 we need to consider. That is 4, 2 plus C of 4, 3. Current city is 4. Next you can visit 2 or 3. That is the meaning. Plus G of, here comma, G of, after visiting 2, what is the remaining city? 3. Choice is 3. Here, function if you are considering in the sense, after visiting 3, what is the choice? That is 2. That is the remaining city. Okay. This is the current city you are visiting. Next, you are going to visit second city. And after visiting second city, what is the remaining city? That is third one. Here, if you are considering currently you are visiting fourth city. Next, you are going to visit third city. After visiting third city, what is the remaining city? That is 2. Okay. Minimum of C of 4 to 2. Cost is 8 plus G of 2, comma 3 cost is 15, comma C of 4, comma 3. 4, comma 3 cost is 9 plus G of 3, comma 2 cost is 18. So here we will get minimum of 8 plus 15 cost is 23, comma 18 plus 9 cost is 27. Which one is minimum? 23 is minimum. That we will consider. Okay. So this is case 3. Next, consider case 4. Case 4 is nothing but from the first vertex, what is the next vertex to be visited and what is the cost for that? That is 1 to 2, 1 to 3 and 1 to 4. We are going to calculate the cost now in case 4. And here if we are considering G of 1, tour has started with the starting city. And after visiting the starting city, you have visited in any order all 3 vertices. Okay. And to return back to the starting city. That is the meaning. So here if you are considering in the sense C12, C13, C14. So now in case 4 if you are considering in the sense we are constructing the first level. That is from the starting vertex you are visiting the second vertex. What is the cost? From the starting vertex you are visiting the third vertex. Then from the starting vertex, you are visiting the fourth vertex. Okay. So, C of 1, 2 plus the function G of 2, comma, and then after visiting the second vertex, what is the next vertex you are going to visit? That function we will add here. Okay. Similarly, we will continue for C13 and C1. So, here if you are considering in the sense, that is the function is C12 plus visit the second city, then visit the third and fourth city. Okay. And come back to the first city. In that case, cost is C12. Cost is 10 plus G of 2, 3, 4. 2, set 3, 4. Cost is 25. So for this case, you need the previous case values. That is case 3 values. Okay. So here we will get 35. Similarly, C13 if you are considering C13 plus G of next city you have to visit 3. And after that you have to complete 214. That is the meaning. Okay. And come back to the starting city. So C123 if you are considering in the sense cost is 15 plus G of 3, set 2, 4. Cost is 25. So here we will get 40. Next, this is C14 plus G of 4, you are visiting 4. The remaining cities will be 2 and 3. Okay. So C1 to 4 cost is 20 plus G of 4, 2, 3 cost is 23. 43. So among these three costs, which one is minimum you need to consider? So minimum cost is nothing but 35. So the optimal path is 1 to 2, 2 to 4, 4 to 3 and 3 to 1. So 1 to 2 cost is 10, 2 to 4 cost is 10, 4 to 3 cost is 9, 3 to 1 cost is 6. And the total cost is 35 and this is the shortest path to complete this two. And this will be considered as the optimal cost. So in this session, we have discussed one example to implement traveling salesman problem using dynamic programming approach. In the next session, we will discuss one more example to understand better by implementing dynamic programming approach. Thank you for watching this video.